everyone, welcome to Mega's tutorial. In today's class we are going to study about the ray optics and optical instruments of second year PUC. This chapter covers the reflection and refraction phenomena. Then we are going to study about the total internal reflection and mirror equation. Then we are going to study about the relation between focal length and the radius of curvature. Then we are going to study about the telescopes and the microscopes. Okay, so let us start with the first phenomena, that is reflection of light. In the previous videos we have studied already about the electric charges in the fields, electrostatic potential and the capacitance, and the current, electricity, then moving charges and magnetism. And all the previous chapters videos are available in my channel playlist. You can visit my channel for the videos. Okay, in ray optics and optical instruments, first we are going to study about the reflection of light. Reflection of light means reflection of light antandre ಏನು, it is nothing but the phenomena in which when a ray of light is incident on a surface, this is the surface here, when a ray of light is incident on this surface, it bounces back into the same direction, that in the same medium, then it is, this phenomena is said to be reflection of light. Here in the diagrammatic representation we are having PO is the incident ray, OR is the reflected ray, QO or OQ is nothing but the normal drawn to the surface. This is the how we represent the reflection of light. For this reflection of light we are having two laws here. The first law states that angle of incidence is equal to angle of reflection. Angle of incidence is equal to angle of reflection, that is angle of incidence will be equal to angle of reflection. This is the first law. The second law states that the incident ray, the reflected ray and the normal at the point of incidence all lie in the same plane. Means the incident ray, the reflected ray and the normal at the point of incidence all lie in the same plane. This is the second law of reflection. These are the two laws of reflection. What is reflection of light? What are the laws of reflection of light? Then we are going to study about the spherical mirrors. Let us consider this as the concave mirror. Okay. Say this is the pole of the mirror. This will be the principal axis. This will be the principal axis. Let us consider this as the principal focus. So we have to study some of the terms here. Say for example, what is pole or what is principal focus, what is center of curvature and focal length. Then you will be having the radius of curvature here. When a ray of light is incident on the mirror, take this as M. N is the mirror. When a ray of light is incident on the mirror, it reflects back. In case of concave mirror, when number of rays are passing through this, they reflect back into the same direction. Okay. So after reflection they are going to meet at a point here, the point at which the rays of light after reflection appear to converge. Converge means they appear to meet at a point, that is called as principal focus. This is in case of concave mirror. Concave mirror. Suppose we are having convex mirror, then the rays of light when they are incident, they appear to diverge from a point. The rays of light, they appear to diverge from a point. Such a point is called as principal focus. This is in case of the convex mirror. Convex mirror. Okay. Then what is principal focus? It is nothing but the point at which rays of light after reflection, okay, they appear to converge in case of concave mirror or appear to diverge from a point in case of convex mirror. Such that point is called as principal focus. So P is nothing but the pole of the mirror. It is nothing but the center of the spherical mirror is called as pole. Okay. So F is nothing but the focal length. Focal length means it is the distance between principal focus and the pole of the mirror. And the distance between the pole of the mirror and center of curvature is taken as the radius of curvature. Okay. This is nothing but the imaginary line. It is called as principal axis. An imaginary line which passes through the pole of the mirror and center of the curvature. It is called as principal axis in case of concave mirror and also in case of convex mirror. These are some of the terms we are going to use next in the derivation that you have to know, and in the exam they may be asked for 1 mark. What is principal focus, what is pole, what is center of curvature, what is radius of curvature, and what is the focal length. Such terms will be asked for 1 mark. There are 5 sign conventions for the spherical mirror. All the distances are measured from the pole of the mirror. This is taken as the pole of the mirror. First sign convention is all the distances are measured from the pole of the mirror. Second one is the distances along the direction of incident light are taken as positive. Say this is the direction of the incident light. We are representing here, this is the direction of the incident light. These distances which are all considered along the direction of the incident light, they are taken as positive, and the distances opposite to that of the incident light, direction of the incident light, they are taken as negative, and the heights downwards or heights below the principal axis, they are taken as negative. Heights upwards or height above the principal axis, this is the principal axis, above this principal axis the heights are considered as positive, below are considered as negative, upwards or the above the principal axis they are considered as positive. So we are having 5 sign conventions here. Okay, they will be asking in the exam, write the sign conventions of spherical mirror. If you are asked for 3 marks, 3 sign conventions are enough, because in physics we are not having provision for half marks. Each answer, each point carries 1 mark. If you are writing the correct answer, you will be given 1 mark, or if you are writing the wrong answer, you will be given 0 marks. So there is no provision for half marks. You have to write 3 if you are asked for 3 marks. If you are asked for 5 marks, have to draw this diagram and write all the 5 sign conventions of the spherical mirror. We are having the derivation of F is equal to R divided by 2. That is, F is nothing but the focal length and R is nothing but the radius of curvature. For this, let us consider the diagrammatic representation. Mn is nothing but the spherical mirror. This is the incident ray of light and it undergoes reflection. F is nothing but the focal length, R is the radius of curvature, P is pole of the mirror, F is the principal focus, C is center of curvature, theta is angle of incidence here. Okay, from this diagram we can draw, let us draw a perpendicular here. For this principal axis, let us draw a perpendicular at D, that is MD is drawn perpendicular to the principal axis. Then angle MCP, it is equal to theta, and angle MFP, is equal to 2 theta. Take this as equation number 1. In maths, you are going to study about the sin theta, cos theta and tan theta. Now here, take the values of tan theta for both these triangles. That is AMCP. Tan theta is equal to MD divided by CD. MD divided by CD. Okay, MD divided by CD. Then and tan 2 theta This is equal to md divided by fd, md divided by fd. For small values of theta, that is for the paraxial rays, this tan theta value, it will be approximately equal to theta, and tan 2 theta will be approximately equal to 2 theta. Okay, tan 2 theta will be approximately equal to 2 theta. Now these equations become, if tan theta is approximately equal to theta and tan 2 theta is approximately equal to 2 theta, then this equation becomes md divided by cd is equal to theta and md divided by fd is equal to 2 theta. Take this as equation number 2. These two combined, take it as equation number 2. Now we compare equations 1 and equation 2. Sorry, on comparing these, not comparing equations 1 and 2, md by cd is equal to theta and md by fd is equal to 2 theta. Then we can write these equations as md divided by fd is equal to 2. Theta value is already known here. This is md divided by cd, 2 into md divided by cd. Okay. Now md and md cancels. Remaining is 1 by fd is equal to 2 divided by cd. Okay. So fd value, fd is nothing but the focal length here. 1 by f is equal to 2 into cd. cd is nothing but the radius of curvature. It becomes c divided by, 2 divided by r. 2 divided by, we got that 1 by f is equal to 2 divided by r, or f is equal to r divided by 2. This equation shows the relation between focal length and the radius of curvature. In your final exams, this will be asked for 5 marks. You have to draw the diagram, then you have to derive the expression up to f is equal to r by 2. Stepwise you will be given the marks. Okay.